Hi everyone, my name is Sadaf and welcome to the first video in a series of what's new in vSAN 8. As you might know, vSAN 8 was introduced in August 2022, which includes an alternate architecture called vSAN Express Storage Architecture with many new features and enhancements. But if you haven't had a chance to go through it yet, don't worry, I'm here to help you to understand this new architecture and show you how easily you can deploy and manage vSAN 8. But before starting, if you want to get notified when I add a new video, please remember to like and subscribe to the channel. So now, without further ado, let's start. As I mentioned at the beginning of this video, the vSAN ESA is not a replacement, but an alternate architecture optimized for high-performance modern hardware. So if you're already using vSAN with the original storage architecture, or basically the architecture we are all familiar with, you can still continue. This is actually one of the common questions we get from customers concerning whether the Express storage architecture would be replaced with original storage architecture, and the answer is no. ESA offers a high level of performance, scalability, and resiliency, and in fact it's a next generation storage architecture for the workloads of today and tomorrow. But first, let's compare how vSAN OSA and ESA are different at a high level. As you might know, in vSAN OSA we have a two-tier architecture, meaning we need to create disk groups, and within each disk group we have cache and capacity tier, and in that architecture we can have a wide range of storage devices. In contrast, vSAN ESA is a single tier architecture, so instead of creating a disk group, we have a storage pool with a high performance NVMe based flash devices, and every single device will contribute to performance and capacity. And again, in vSAN 8, you have the possibility to choose either OSA or ESA architectures. But bear in mind, if you want to build a cluster based on vSAN ESA, you need to use vSAN ESA approved ready nodes. But if you are thinking about the specifications, it depends on the profile you choose for the servers based on your needs. ESA is not just an answer for a large customers with a huge amount of data, but it can also work for small environments like Edge. So VMware recently announced a new ESA Ready Node profile, which is ideal for small data centers and edge locations. But this profile is applicable for vSAN 8 Update 1 and later. In ESA AF0, the network bandwidth has been mentioned as 10 gig, but is highly recommended to go with 25 gig instead. I also put the vSAN ESA Ready Node hardware guidance link in the description of this video. Other than this, you need to have the vSAN Advanced or Enterprise license based on the feature you want to achieve, for example vSAN Stretch Cluster. And now let's highlight the main enhancement in vSAN ESA, which comes into 4 different categories. First, you get a better performance without a trade-off. But what do I really mean by that? Well, you can store data using RAID 5 or 6, but at the performance of RAID 1, and you will have a minimal performance impact when you take a snapshot. Besides that, vSAN ESA can improve up to 70% more usable capacity and improve CPU efficiency. The next enhancement is around improving high availability by reducing failure domains. So for example, if one of the storage drives within the storage pool fails, it doesn't affect the storage pool and you can simply replace the failed hard disk. And lastly, managing and configuring vSAN ESA is way simpler. But let's quickly check what it has been changed in this architecture that vSAN ESA brings these enhancements. First is a vSAN log structure file system or LFS. And the second thing added to this structure is the optimized data structure that help us to store data with the best performance and efficiency. These two structures allow vSAN to write many small IOs quickly, unify them, and write a large block. At a high level, incoming IO is compressed, unified, and packaged with the associated metadata. Then it will be written to a persistent, durable log that is known as performance leg. So if I want to explain it simply, when a write IO comes, it will be stored in the performance leg with the RAID 1 method, and then when it reaches to 512 kilobytes, a full stripe write to the capacity leg would take place. This is how vSAN ESA provides the same performance at the RAID 1 level, although data would be stored at the efficiency level of RAID 5 or 6, because it allows vSAN to return the write acknowledgement immediately to the guest VM and keep the latency low. One of the other changes compared to the original architecture is that vSAN ESA will distribute the data in a different way. So the number of components stored in the performance leg and capacity leg would be different. For example, if we have a RAID 6 with FTTX capacity to, you will have 3 mirrored components in the performance leg, which is 1 object and 2 mirrors because we are going to tolerate 2 failures, and then in the capacity leg we will have 6 components across 6 hosts. And then when it comes to RAID 5, because we tolerate 1 failure, we will have 2 components in the performance leg and 5 components spread across 5 hosts. Wait, I just said 5 components, but why? Didn't we have a 3+1 schema for RAID 5? You're right, in vSAN OSA we only have 1 schema for RAID 5. But in vSAN ESA, there are 2 alternate schemas based on the number of hosts you have in the cluster. If you have 6 or more hosts in the cluster, vSAN ESA will automatically choose the 4+1 schema and spread the components across 5 hosts. And if the number of hosts in the cluster due to a failure or maintenance reduces to 5 or fewer hosts, the RAID schema from 4+1 would be automatically changed to 2+1 after 24 hours. So you don't really need to be worried about changing it because it will happen automatically. Now let's move on to my lab environment to show you how easily you can configure and manage vSAN ESA. I have already logged into my vCenter server and I have 2 clusters, one based on vSAN OSA that has already been configured, and in the other one I have 6 ESXi hosts that I haven't configured for vSAN ESA yet. My vCenter server and ESXi hosts are running on version 8 update 1, and later in the coming videos we will upgrade it to 8 update 2 together. There is a warning on my host, but it's only because there is no data store has been configured yet. Besides the management, I have also configured vMotion and vSAN VM kernel adapters for each ESXi host in the cluster. And please consider that I'm running my lab in a nested environment and I have 4 300GB drives that I will use for vSAN ESA. Besides, I have 2 10GB network adapters, but for production you need to have 25GB network adapters. And now, as I showed you how my lab has been set, let's start to configure vSAN ESA. I go on my vSAN ESA cluster and from the Configure tab, under vSAN Services, I choose I need a local vSAN data store. And as I want to configure a standard cluster, I don't change the selected option and I choose Configure. Here, as you can see, there is a toggle button that you can choose whether you want to configure the cluster based on ESA or OSA. Besides an overview of the main capabilities that vSAN ESA offers, here as I want to configure vSAN ESA, I choose Next. In the Services section, you will notice that the Space Efficiency option has been selected by default. This is actually one of the differences between vSAN OSA and ESA. If I want to compare how compression is configured in the original storage architecture versus ESA, I would say compression was a cluster-based feature in OSA, so you could enable or disable it only on the cluster level. But in ESA, compression is enabled by default on the storage policy level. If you want to disable it, you can clone the default storage policy, disable the compression and apply it to the VM or the VMDK, which I will show you in the coming videos. The other difference is that with vSAN ESA, compression applies at a higher level of the vSAN stack. So in this way, we reduce the overhead of CPU and network, and it is because data is being compressed once at the source ESXi host, and when data is being transferred over the network, it is already compressed. This is the reason the compression is enabled by default. The last difference is that in the original storage architecture, compression is applied if the 4K data block could be compressed to 2K or less than that. But in ESA, a 4K block will be divided into 8 512 byte blocks, and each block will be compressed. This could potentially lead to 4 times improvement in data reduction compared to the original storage architecture. Then we have an option to configure data at rest encryption, and note that this option is only available when you are configuring the cluster and you can't modify it afterwards. I don't want to configure the encryption for my cluster, so I wouldn't enable it. There is also auto policy management, and based on the type of cluster and number of hosts in the cluster, vSAN creates and assigns a default data store policy for best capacity utilization after the cluster configuration is completed. But please note that this option is available only with vSAN ESA. I will keep it as it is and choose Next to claim the hard disks. I have a warning that states my disks are incompatible, and because of this reason I'm not able to choose vSAN to manage the disks. But as I'm configuring this cluster in a nested environment, so I would manually claim the 300GB hard disk for all of the ESXi hosts and move on to the next step to create fault domains. But you need to bear in mind to use vSAN ESA approved hardware for production. Here you can define which host can fail together. I don't have any specific preference for my cluster, so I move on and finish the configuration. As the configuration has finished, we can check the cluster data store, and I will rename it to be identical as the cluster name. In the next step, I want to migrate one of the virtual machines from my ESA cluster to this new cluster to show you how easily you can migrate the VMs between clusters and manage two architectures of vSAN in the same vCenter server. So I select the VM I want to migrate, and then I choose to migrate both host and data store. Then I choose the vSAN data store of my ESA cluster, and for the storage policy I select RAID 5. After the migration is done, under physical disk placement you can check the performance lag that is based on RAID 1 and capacity lag on RAID 5. As I mentioned earlier, if you get less than 6 hosts in the cluster and your virtual machine's storage policy in the cluster is RAID 5, the RAID schema from 4+1 would be automatically changed to 2+1 after 24 hours. By this we reach to the end of this video and hope it was informative for you. Thanks for watching.